So with our data table, despite my terrible handwriting, you can pretty quickly and easily look at it and see, oh, well, the crucible and lid was 50 grams. Oh, look, I've got a unit there with grams. I labeled what the thing was. It doesn't just say 50 grams somewhere on the page, and we can figure out what that is, right? And then it says crucible, lid, and magnesium. So a mistake that students will make sometimes is they'll weigh the crucible and lid, and then they'll take the lid off, put the magnesium in, and weigh the crucible and the magnesium with no lid. Well, in order to figure out what the mass of the magnesium is, I need to be able to subtract off this other stuff. So I need everything that was there before. So that is a problem that will sometimes happen. And then crucible, lid, and product. Well, when we burned it, what happened was it went from magnesium to magnesium oxide. So it did actually get heavier, which is really confusing for a lot of students. Unless you really messed up, it got heavier, right? Because you were adding oxygen to it. Intuitively, we think that when things burn, they get lighter because you're used to organic or non-metals burning. And when non-metals burn, they make gases, and those gases float away. But they're still heavier in total than what was there before because you're adding oxygen to it. So when I go to do the calculations, I want to label those calculations. I don't just do things wherever, right? So I'm going to label mass magnesium. You can even number them, right? So mass of magnesium, and then I'm just going to write it down. 51 grams minus 50 grams. We will keep these zeros and stuff because that shows that those were measured zeros. Now I use rounded numbers here, so everything's really easy. Don't like round numbers, right? Because we want to keep any information that's there. And once we round those, then we've lost that information. But that means I'm going to have 1 gram of magnesium in mine. But I'm still going to write down 1.00. That way people know that we measured clear to the nearest hundredth because that's what our balances measure. If we just wrote down 1, they would assume that we only measured to the nearest 1 gram. Right? Same thing for the mass of my final product. Would be the 51.6 grams. Now I'm going to subtract I want the whole product. So some of that is magnesium and some of that is added oxygen. So I would subtract off the 50 grams again. And that's going to give me 1.6 grams of product, which is, if I could write, that would help, which is magnesium oxide, right? And we're trying to figure out what the formula for that is. So there's that, right?
Color coding, I have to draw the...
So then for the mass of oxygen, right, that's going to be the difference in these two or the difference in these two. Either way, it's going to be 0.6 grams. I'm out of space here. So we'd subtract that, and that would be our mass of just oxygen. But again, look at, you can tell what things are what right there. It doesn't take that much longer to write it out so that people can read it, and anybody can come along very quickly and tell what we've done here. Because we've got not only labeled mass, but labeled a mass of what it is, and we've got units on things, and we showed what math we did. Even though it's easy math, right? Even if it's just subtraction, we can still show that math.